Welcome to this video on A-level Maths Mechanics constant acceleration formula. In this video we are going to use constant acceleration formula, sometimes called SUVAT formula, to solve problems. There are three SUVAT equations you need to know, and in this video we will cover two of them, v equals u plus at and v squared equals u squared plus 2as. For the other SUVAT equation, please sign up to kippersconsultancy.co.uk and find out more. Okay, let's now look at the equation v equals u plus at. This is derived from the definition of acceleration, which is the rate of change of velocity divided by the rate of change of time. Well, the rate of change of velocity is equal to the final velocity minus the initial velocity divided by the time between the final velocity and the initial velocity. So this gives us a equals v minus u over t. And if I multiply through by t, I end up with at equals v minus u. Then I can rearrange to give myself v equals u plus at. V is the final velocity. U is the initial velocity, A is the acceleration, and T is the time. So in our question, where a car accelerates in a straight line at 6 meters per second from a velocity of 4 meters per second, we need to find out how fast it will be travelling in 5 seconds. Let's first of all write down the information in the question. So the car accelerates in a straight line with an acceleration of 6 meters per second squared from a velocity of 4 meters per second. So that sounds to me like the initial velocity is 4 meters per second. How fast will it be travelling in 5 seconds? So we know the time is 5 seconds, and we want to know how fast it will be travelling, so we need to work out its final velocity. So we can see that we can take this information and plug it straight into the formula v equals u plus at. So our final velocity will give me 4 plus the acceleration of 6 times 5, the time. So 6 times 5 is 30, plus 4 is 34 meters per second. So our final velocity of the car is 34 meters per second. Let's see how we use the formula v squared equals u squared plus 2as. I'm going to start by deriving this formula. Let us consider the average velocity. This would be the initial velocity plus the final velocity divided by 2. An average velocity is equal to the distance divided by the time. If I now cross multiply, I end up with t bracket u plus v equals 2s. Now, if we take our original formula for acceleration, which we derived from its definition, a equals v minus u over t, we can rearrange this to give us t equals v minus u over a. I'm going to substitute v minus u over a into the original equation I produced. So I've now got v minus u, u plus v over a equals 2s. I'm going to multiply through by a. So I've got v minus u, v plus u equals 2as. We can see that the left-hand side is the difference of two squares. So I've got v squared minus u squared equals 2as. And then with a little bit of rearranging, v squared is equal to u squared plus 2as, and that's the formula we're looking for. Let's see how this equation applies to our example. So We have a motorcycle racer and it has a constant acceleration of 7 meters per second. And I'm going to write down the information in the question as I read through it. It passes the start line with a velocity of 25 meters per second. So that sounds like the initial velocity is 25 meters per second. At the end of the straight, it passes a speed trap. What should its speed be if the distance from the start line to the speed trap is 600 meters? So we know the distance is 600 meters and we're looking for the final velocity. So we can see here that we would use v squared equals u squared plus 2as. And we substitute the information from the question into the formula, which gives me v squared equals 25 squared plus 2 times 7 times 600. So the final velocity is equal to the square root of 25 squared plus 2 times 7 times 600. And when we put that into a calculator, we end up with 38 meters per second to 2 significant figures. Thanks for watching this video on constant acceleration formula. If you'd like to learn more about this topic, then please join us at kippersconsultancy.co.uk. There you'll meet other students and tutors working together to apply their knowledge to solve harder questions, to help build students' confidence and allow them to access higher grades. Thanks for watching. See you soon. Bye.